Hi, today we're going to be looking at relating mixed numbers and improper fractions. Let's look at what that means. So here I have two diagrams. Each represents an improper fraction and the other one represents an improper fraction, the other represents a mixed number. The top one represents a mixed number, and I'll explain why in a second. The bottom represents an improper fraction. Okay. Let's look at why that is. So if we were to analyze this and we were to write this down numerically, we would say, well, there's one big square that's highlighted, two big squares, three big full squares that are highlighted. So you write three right here, three whole numbers, three whole squares are highlighted. And the fourth square, there's one part, two parts, three parts that's highlighted out of a possible four parts. So 1, 2, 3, 4, but the fourth one is not highlighted. So we say there's three full, right? Three whole numbers, three full squares that are highlighted, and 3/4 of the fourth square that's highlighted. And we call this a mixed number. Why? Because you have a fraction and you have a whole number, an integer. If we look at the improper fraction, we could say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 highlighted small squares out of a possible 4 squares in each box. Well, why is that an improper fraction? We call this an improper fraction. If you recall, the top number in a fraction we call the numerator, and the bottom number we call the denominator. Well, as you know, the numerator is usually has to be smaller than the denominator. So let's say 3/4. That is a proper fraction. If the numerator, as in this case, is larger than the denominator, that's still a fraction, but we just call it an improper fraction because it doesn't take the form that the numerator is smaller than the denominator. It's not wrong or anything, we just call it an improper fraction. So that's the difference between mixed numbers and improper fractions. Notice, however, these two diagrams essentially represent the same thing in that they have the same surface area highlighted. This improper fraction is equivalent to this mixed number. So these two are equal. So if you were to write 3 and 3/4 equals 15/4, this would be a correct statement. These two are equivalent. Now, let's look at converting improper fractions to whole numbers. Okay, to convert mixed numbers to improper fractions, simply multiply the denominator with the whole number and then add the numerator. Okay, let's check this out. So let's take this is a mixed number, and let's convert it, okay? So I'm going to use the bottom left hand of the screen to do that. So we've got 3 and 3/4, and we're going to convert this to an improper fraction. So what are the steps? Multiply the denominator with the whole number. This is the denominator, this is the whole number. So we multiply 4 times 3 gives us 12. Then, right, so multiply the denominator with the whole number, and then add the numerator. The numerator is 3, so plus 3 equals 15. Okay, so that's the answer. The answer is obviously the numerator, the new numerator. The denominator always stays the same, so 15/4. Now, where did I get this 4? Because it was a 4 here. The denominator doesn't change. So the answer here is that it gives you the new numerator. And as you could tell, this is the same answer as this. Now, if I wanted to convert this to a mixed fraction, a mixed number, excuse me, we could do it. So to convert improper fractions to mixed numbers, simply divide the numerator, which is the top number, 15, by the denominator. The answer becomes the whole number, and the remainder is the numerator. So let's see how that works. So simply divide the numerator, so that's 15, divided by the denominator. The denominator is 4. Okay, let's go ahead and divide. How many times does 4 go into 1? 0. How many times does 4 go into 15? 3. 3 times 4 is 12. We do a little subtracting. The remainder is 3. So the answer is 3 with a remainder of 3. So the answer becomes the whole number. So this is the answer. So that's the whole number. And the remainder is the new numerator. Okay, what's the denominator? Denominator stays the same, always staying the same. So this is 3 and 3/4 as a mixed number, and guess what? That's correct. That's exactly what that is. Okay, let's do a few together to really get the hang of this. Okay, so let's do some questions together. Write each of the following mixed numbers as an improper fraction. Okay, well, how do you do that? We take the denominator, multiply by the whole number, and then add the numerator. So 6 times 1 is 6, plus 5, 11 over 6. Okay, let's do this again. So take the denominator, multiply it by the whole number, then add the numerator. 3 times 2 is 6, plus 2 is 8 over 3. 8 times 1 plus 4. 8 times 1 is 8, plus 4 is 12 over 8. So we just converted these three mixed numbers to improper fractions. Now if we were to do the reverse, write each of the following improper fractions as a mixed number. We have to divide. So 5 divided by 2. How many times does 2 go into 5? 2. 2 times 2 is 4. Do a little subtracting, that's 1. So that's a remainder. So remainder of 1. So the answer, remember, the answer becomes the whole number, and the remainder becomes the new numerator, and the denominator always stays the same. Let's do this. 9 divided by 4. How many times does 4 go into 9? Twice. 2 times 4 is 8. 9 minus 8, 1. So that's a remainder. Remainder of 1. So the answer is the answer is the whole number. The remainder is the new numerator, and the denominator stays the same. Okay, let's do the last one here. 14 divided by 3. How many times does 3 go into 14? Well, 4 times. 4 times 3 is 12. Do a little subtracting. 14 minus 12 is 2. So that's a remainder. That's a funny R. The remainder is 2 here. So the answer becomes the whole number, and the remainder is 2. 2 becomes the numerator, and the denominator stays the same. So the answer here is 14 over 3 converted to mixed number is 4 and 2/3. Okay, I hope you've enjoyed this video. Thank you for watching.